Hello everyone, so this is Kumar here. I'm back again with another Wednesday Talks. It's been a long time, so I haven't uploaded any videos. So this time I wanted to update on the mainframe COBOL usage of COBOL, usage in COBOL. Okay, so I'm going to discuss about in detail about what is display, what COMP-1, 2, 3, and many of the subscribers have received a lot of comments on can you explain about this COMP-1, 2, 3. Okay, for some people it may be very easy, for some of them it may be confusing to them, and how do we debug this, and how do we understand the value, how do we display them. So a lot of queries been coming up, so thought like let me create one video so that it can be helpful to anyone. Okay, so with that said, let's get started. Okay, first let's understand why we use usage clause, right? So let me tell you something here. When you're working on any of the computers, the computer understands only one and only one language, that is binary language, that is zeros and ones, right? So similar to that, so whenever we are coding in a COBOL, so when we talk about the COBOL programming, here we have an option to specify internal form of the data item using usage class. That is the main reason we are going to use the usage class. So what it will do, so as to facilitate the use of data item more efficiently, obviously, right? So when you're already converting something system understandable format, right? So that way you can I can say like it's more effective, right? So the usage class specify how the data item being stored internally. If no usage specify, the default class usage is a display, right? The usage class can be specified for a data description entry with any level other than 66 or 88. So this is the first thing. This is the fundamentals just I'm trying to explain here. So apart from 66 or 88, so you can use any other level numbers, and also you know that in mainframe the data is stored in an episodic format, right? Okay, what is the benefit of it? It leads to results in faster computation and effective memory utilization. Okay, so we'll be seeing, so what are the different types of usage classes that we'll be seeing is one is display, other is COMP-1, COMP-2, COMP-3, and there are COMP-4 and COMP-4. So as the versions been upgraded with the enterprise level, we will be seeing enterprise COBOL level more than I think 2.1 above versions. So they can see right now it's a 6.3 or 2 version that is going on. Okay, so we can see COMP-4, COMP-5, I mean, which is equivalent to binary storage or the COMP or computational storage. Okay, so these that's a pretty introduction about this. And another important thing, especially when you're working in an finance project, or I can say like the banking domain or the insurance domain, so where the transactions, the amounts calculation is required for the faster computation and effective memory need to be utilized, right? We wanted a quick result, the quick calculations, quick business logic has to be performed. So in that case we are going to use a computational usages, I mean the usage clauses. It can be a COMP-3 or COMP-1 and COMP-2. It depends about the situation where we have to use and we are going to use it. And another thing, so I'm not sure if anyone of you have worked on the DB2 environment, so maybe you have already noticed that whenever you have a DB2 table, when you convert that to a copybook of COBOL formatted copybook, you see a COMP-3 or a COMP variables that is being automatically converted. The int is converted to COMP-3. The reason, the first point that which I have mentioned, right? The usage class specify how the data item being stored internally, right? So this is the internal form of the data that's being stored using the COBOL. So that is one thing that we can see. And not only the DB2, if any kind of an exchange that is happening between one system to another system, so mostly if anyone working in an ETL especially, the data transmission happens from one system to another system, or FTP or load unload, All these things comes up, right? So there we will be using COMP-3. The most common reason is the transactions are more, the volume is more. If you are just using the display, the default one, just declaring line of 3 and just trying to calculate, yes, it works, but what about the faster computation? What about the effective memory utilization? What about the performance, right? So we need to, as a good programmer, so we need to make sure we are doing all these check things, right? So that's where it can be. If you're working in an ETL, if you're working as an ETL developer, or if you're working as a tester, or if you're working any of the COBOL DB2 projects, if you're working on an online or system, or if you're working in a batch system, so wherever it is, you will be seeing this, and it's a very, very, very important topic I'm saying. So that is the reason I'm trying to explain more. So I may take more time in explaining all these things, but we need to understand why we are using this. So that is the reason I wanted to tell or share my experience on this. Okay, so let's move ahead. So now I'm going to explain you a few basic things. Let's understand. Let's go back to our college days or school days. So maybe, okay, what is nibble? Nibble is nothing but it's a 4 bits. 4 bits is nothing but it's a one. We call it as a one nibble. In packet decimal, each nibble stored 1 digit. That means when you're using the COMP-3 variable, so it's called as a 1 digit. Normally, 8 bits. If you are having an 8 bits, that is 1 byte, where we store a 1 digit. Okay, so especially you are handling with the characters, so it's a 1 byte. Okay, byte is nothing but it's a 8 bit. Half word means what is 16 bits or a 2 bytes. Full word means what, 32 bits or a 4 bytes. And double word, so it's a 64 bits or an 8 bytes in is one double word. Okay, now we are getting started. So display, I mean, this is the observation, my observation, so where I have seen based on the experience. So display means normally character type that comes into the picture. It doesn't mean that we have to use only for the character, we can also use for numeric as well. So by default what comes to my mind is display means it's a character. So the comp, so whenever you wanted to handle with the integer data types, integer kind of an information you wanted to store, so you can use the comp. And similarly comp-1 and comp-2, where we don't code any picture class for this. So and if you want to have a fractional numbers containing a decimal point, or it stores the floating numbers or the real numbers, so we can use comp-1 and comp-2. And comp-3, comp-3 is a packet decimal format, that is a half byte, right? So half byte means what? So nibble means 4 bits, right? So it will take one character as a nibble. Okay, instead of taking as a 1 byte, so it takes as a nibble. Okay, especially when we are using an amounts, billings, banking, finance, credit cards, debit cards, personal loan, home loan, so whatever the products they are, which deals with the amount transactions, right? So we use mostly the comp-3 and comp. Okay, so this is what the things that we are going to look more in detail. So it's just a simple snapshot of it. So let's talk about the display. What is display, right? Usage of display. Display data item is stored in a character form. Each character of the data is represented in 1 byte, and the default usage of the data is anything. If you are not specifying any usage, comp-1, comp-2, comp-3, by default it is a display usage. This format is suitable for character manipulation. So based on the experience I'm saying that. So what are the data types display is used? You can use alphabet, alphanumeric edited, and the numeric edited. All these go in. So whatever the data that you pass on, right, if you're tossing 8 bytes, so 8 bytes is stored there. Okay, there is no I can say no memory saving here. Okay, the number of bytes required to store a data item is equal to the size of data item. Okay, and for example, so if you want to write a name, so even if 019 picture name usage is display, how many bytes is storing? 5 bytes. Here 5 plus 3, 8 bytes. Here 5 plus 3, 8 bytes. So even if you write the display or if you don't write the display, still it going to work similar way. Okay, here is a simple example that I want to show. So what you are trying to do with the display, I'm just trying to pass this data here A234 to this, and I'm trying to display this, and what should be the length of it, right? So it should be 5. And similarly without display, I'm trying to run it and it will display the length of it. So obviously it will display 5. If you want me to connect to the mainframe and show it, yes, I can do that. Or let me connect to the mainframe right away and show you. Okay, so this is my program. So whatever I have shown there here. So first is I'm using usage display, and next I'm not using anything. The reason I've just told, like, if you're not using anything, so by default it will be the display. Okay, so I have compiled this and let me run this and go to the output and see how it goes. Okay, let's see the output. I want to see the length. You can see the length is 5 bytes and the 5 bytes. How much what we have declared here, it's a 5 bytes. So whatever the memory is given, so only that will be stored there. Okay, so that's about the display. Now let's look at the comp. Okay, so what is comp? Comp usage is a comp and indicates the data item is stored in a binary form. So it is bits and byte. Okay, it deals with the integer number. So earlier we were telling the display is more kind of a character, but we can also use there. It deals with the integer number. It is specified for binary items, and here we are going to save the memory. Okay, so how? So S90124 half word, so that means it stores the 2 bytes. 5 to 9, so full words, that means it stores the 4 bytes, and 10 to 18 it stores the 8 bytes. So this is how, even though it ranges from 10 to 18, it stores 8 bytes. Even though it is ranging from 5 to 9, it stores 4 bytes. Okay, so that's how we are going to save that. So this is what happens, right? So 1 to 4 range 2 bytes, 5 to 9 4 bytes, and 10 to 18 8 bytes. If you look at the example here, right? So what I'm trying to do, usage is comp. Either you can write saying that usage is comp, or simply you can type comp. So both are the same. So maybe if you have changed the company, you're already working in one organization, you move to another organization, there the code they may see, you may be seeing is usage is comp. Some people may written, some programmers may write just with the comp. So don't get confused. So both mean a same. You can do a trial and error and you can try testing and check it out. Okay, so W1 is comp snum, S9 of 04, S9 of 6. I'm trying to take a signed integer and an unsigned integer as well. So we are trying to test this. So how the, and when we check the length of these things, suppose if I'm giving a 4 means how many bytes it should occupy? 2 bytes. Similarly 6 means it should occupy 4 bytes. 11 means it should occupy 8 bytes, right? So I'm trying to test this. Let's connect to the mainframe and see how the output comes up here. Okay, so here is the program that you see, and what we have typed, this is the usage is a comp and the comp variable. So what I'm trying to do, since this is signed integer, so I'm trying to pass some plus 1 2 3 4, and at the same time I'm also trying to check if I can do a compute or addition, and trying to display, and then at the same time I'm trying to check for the length of it and see how it works. And similarly I'm passing some 6-digit number and here 11-digit number and so on. Let me compile this and see. Let me submit this. Okay, it is getting compiled and it has run. And let me also run this. Okay, comp, okay, and submit this. Awesome. So let's go ahead and check the output, how it looks. Okay, so if you look at this, the first one, what was the let me close this. Okay, I don't need this. Okay, so first initially we have given S9 of 4, right, and it's a usage is a comp, right? So 4 means 1 to 4 it should occupy 2 bytes. So if you look at here, it is storing 2 bytes. Similarly, and 6 means it should occupy 4 bytes. Yes, 4 bytes, and 11 means 8 bytes. So you got it, right? So this is the most importance of it. So when we are using a large number of transactions, and if you have 50 fields, 60 fields, some 70 fields of data where you wanted to compute this, it becomes very easy when it is lighter the weight, so more you carry, right? So more you run, I can say. Okay, so that's how it goes on. So it will be easy for this. So that's about the comp, and each has, you know, 1 to 4. The range, the value of the ranges that you can copy is -3 to 7, 865, 862, 3 to 765. And similarly, if you want to store the numbers in billions, you can take a different range. If you want to store the numbers in trillion dollars, yes, you can just change the range of the data. So that means S9 of 10 or 11, you can use it, and you can store the value accordingly. Okay, so I'll show you. I mean, I have a different chart prepared for this, how a value can store. I mean, everyone says like mainframe is a big computer, so it can process. I mean, why? Because all the big banks are running. I mean, if you look at any of the bank, if you take any top banks, either any of the countries, right? They rely on mainframe, right? All the trillion-dollar transactions, $1 billion transaction that is happening in the banks, right? Or it can be the government sector, it can be a private banks, right? So this comp variables plays a very key role there. So they need to calculate those numbers. I'll show that in a separate chart there. Okay. So now let's look at the COMP-1. So what is the purpose of this COMP-1? So mainly it's suitable for arithmetic operations, as I've mentioned, represented using one word, that is 4 bytes. Whatever the value you store, so it just takes only 4 bytes. Okay, so there is no picture class. Another thing is there is no picture class. Why? Because sometimes we think like, okay, I need 9, 4, 5, and just you code the integer value there according to that, and you declare picture class is 9 of 4, or sometimes it's 9 of 10. Sometimes you don't know what value you wanted to assign, so then blindly go with the comp1, and it dynamically takes whatever the value that you give, it processes, and it gives you the results. Okay, so that's the beauty of the comp1 and comp2, and there is no picture class, and always it stores the 4 bytes. If you want to print 1000, 2000, million, okay, so it takes those things. It is internally stored in a hexadecimal format. Okay, and this is a simple program that you can see, comp1 of a, comp1. So this is how. Do you see any picture class here? No, not at all. So you'll be not seeing any picture class here. And what I'm trying to do, I'm trying to do some move operation. So as I've told, since there is no picture class, I can pass on any value, and you can do any kind of arithmetic operation that you want it to do. Okay, so 1.234 display, and I'm trying to check the length of it. So it will display obviously how many bytes it is stored, right? 4 bytes. Even if you check this, it will store 4 bytes, so it will not exceed or not decrease. So by default it will check, it will take whatever the value that you did. But the only thing is, it is stored internally in a hexadecimal format. What does internally hexadecimal format means? For example, let's take the number 1.234 can be represented as plus. Why? Because it is internally taking if as a positive integer, so the plus is being assigned, and it tells like 0.1234 into 10 to the power of 1. 10 to the power of 1 means 1. That will be considered as 1.234. Okay, plus is the sign of the number. 1 in 10 power 1 is the exponent, and 1 to 3 is 4 is called as a mantissa, which is represented using 3 bytes. So this is this chart show you. See, 1 stores in 1 bit sign, the positive stores 7-bit exponent, and 24-bit mantissa. So this is how the internally hexadecimal format, so the data is being stored. When you look at the output, so the output will be printed here. So since this is a 1 dot, so it stores in e power 01. And what is the length of it? So it is a 4 bytes. Even if you print this, it will be in a 4 bytes only. Okay, so similarly for the comp2, it's suitable for again arithmetic operation, and there is no picture class, and it is a 2 words. 2 words means 8 bytes, and there is no picture class, and it is internally stored in again hexadecimal formats. The simple change I have done is, instead of comp1, I have coded it as a comp2. So it's the same thing, and I have tried to print and check the size of it, the same value, but I have taken it as a comp2, and you can see 8 bytes. So 8 bytes it has taken, and if you can see the zeros are also increased, right? So it depends upon if you think like the arithmetic operations, it is going to some $1 billion, go with COMP-2, so that the range occupy will be more. I mean, if it is in just in thousands, hundreds, right, 100Ks, then you can go with the COMP-1. Okay, so number 1.234 can be represented in this way. The plus in the sign number, and exponent 1234 is this way. And if you look at here, so all together when you combine, it forms as a 64 bits. 64 bits means 8 bytes, right? So whereas earlier it was 2 bytes, right? Sorry, 4 bytes. So 4 bytes means 32. So 24 plus 7 plus 1, 32. Okay, so now here you can see 64. So this is the form that internally the data gets stored for COMP-2. Okay, if you want me to show it on the mainframe, I can show it to you. So one second. Okay, so this is about the COMP-1 that we have seen. So first thing is I need to compile this. So let me run this. Okay, compile successfully. So just I wanted to make sure, why, because when I'm presenting it, when I'm showing you the code, just wanted to make sure that code works perfect, and when you're trying from your end, so it should also work, right? So that is the reason I'm making sure it works fine. Yeah, it ran good. And let me show you here how it goes. Now you can see, so it is internally stored in hexadecimal format, and if you look at the length, 4 bytes, and the 4 bytes for the same value. So here for this also it occupied 4 bytes, and for this also it occupied 4 bytes. And you can start adding any kind of an arithmetic operations if you want to add and see. Okay, so for example, let me do something. Okay, let me compute ws comp1 of a equal to ws comp1 of a. Just I'm trying to add the same value repeatedly. That means 2 dot some 4 6 8 it should come. Okay, so okay, I have opened in a view mode. Let me cut this. Okay, and edit this, del all nx, paste. Okay, so that I'll no need to write that back again, save, and okay, usj submit. Okay, it ran. Okay, so it's not trying to. What happened here? Comp. Okay, I missed one here. Okay, right. So let me recompile now. Okay, it ran good. And where is run? So let's run this and see whether the arithmetic operations are working or not. And let me see the output. No. So come on. Okay. Okay. Why this is not moving? Okay, there is a 1 second. Let me purge this all. Okay, let me purge this completely. Okay. Okay, let me recompile. Okay. Okay, I'm sorry, I'm continuously compiling that instead of running it. Okay, here is the sorry. Now you can see that 2468, right? So what was the 234 converted to 2468, right? 2468, right? So you can see that value. So So this is how I mean you can use an arithmetic operation for both COMP1 and COMP2. Okay, so when you run this COMP2, right, so for COMP2 as I said, it occupies 8 bytes. If you want me to show that as well, I can show you if there is no time. Yeah, so let me show you that. Okay, but I'll change this to COMP2 and run this. Okay, it ran good. And similarly, let's run this as well. It should occupy 8 bytes there. Okay, yeah, awesome. Okay, and check this output. Okay, now you can see 8 bytes and you can see 8 bytes. Okay, so that's about the COMP1 and 2. Now let's move on to COMP-3. What is COMP-3? It is mainly used for packet decimal format, as I have told in the beginning. So when you are converting some integer long int variables in the DB2, so it will be automatically converted to COMP-3. So the COMP-3 will consider 2 digits as a single byte, and it saves lot of space. In general, each digit occupies, normally each digit occupies 1 byte if you are not using any comp. So whereas COMP-3, 2 digits is considered as a 1 byte, and 1 half byte will be taken care by sign. Okay, so that's about the COMP-3. Okay, so and sometimes what happens is whenever you're trying to display a comp variables, right, so you are not sure whether the value that you are seeing is a negative value or a positive value in the comp. So how do we determine that? Whenever you see plus this particular symbol, that means that represents 0. Similarly 1. So okay, so this is the complete table. Just for a reference I am showing you, but I have to talk more in detail about COMP3. So when I'm trying to display something, so you may see if some sudden surprise output in the output there. So to avoid that, just I wanted to show you here plus 0. Whenever you see this kind of an information in the input data, especially if that data is a comp variable, so that means you will be checking, you need to, that means you need to map it to this. Okay, you see when you see O, that means -6. Okay, so that's about this. And okay, so here is an example. Whenever you see this COMP3A 9 of 4, so value, and just what I'm trying to do here is I'm trying to pass some 12 value to the 9 of 4, and similarly signed and signed positive integer and unsigned. This is an unsigned integer, so these are like signed integer. Sometimes I'm passing a negative value, and you can also pass positive value, and also you can do some arithmetic operations also. So WS COMP3A, and trying to display a length, as we know that so this 4 means it stores half a byte, so 4 means 2 and 1 byte for signed, so that means it occupies 3 bytes. Similarly 3 means 1.5 plus some signed integer, so that means 2 bytes it will take. Similarly 5 means 2.5 plus half, that is 3, and similarly 3. So this is the expected output. So when you run this, so you look at here 0 1 2, since it is a 0 0 1 2, since you have given 4 bytes, so it places 2 zeros there, and the length is 3 bytes, 2.5 plus 1.5, and 0 1 2, and you can see the 2 bytes, and 0 0 2, since we have taken 5 bytes, so you can see that, and 0 1 k. K means what do you mean by k? -2, right? So when you see k, that is -2. So what is happening here? See, 1 -2, -2, k is nothing but -2, that means it's -12, right? So just I'll show you again. K means what? -2. So how it is showing, how we can see here, how it is printing 0001 k. And similarly, when you are trying to move this value to just a signed integer without usage class, and if you are just moving this value to the signed integer, so either if it is a negative value, so the data will be printed in this way. So just keep this reference chart, and whenever you see that values at the end, so just convert it to this. Whenever you see I, so that means it's a 9 at the last. Okay, So that's the main advantage, and similarly we can use it for the fractional numbers also. So decimal points, so 9 of 3 v 9 of 2, so 123.45. And similarly for this signed integer and unsigned integer, what would be the output? So 12345, and it occupies 3 bytes, and next one occupies 3 bytes, and similarly this occupies 4 bytes. And you can see n. What do n stands for? It is showing 123.45. what do you mean by n here? Okay, n is minus 5. So do we have minus 5 here? Yes. 1 2 3 4, last what it is 5. 5 means minus 5, n means dot minus 5. So this is how we can easily understand this comp variable. So this is where most of them get confused. Okay, so just keep that chart, so it is very easy. Okay, so I said right initially, so the value ranges. So the value ranges starts from S9 of 1 to 14, so we call it as a binary half word, and the numeric values ranges from 32768 to 32767. And similarly for S9 of 59, so if you value, if you think that when you have given, when someone has taken a savings account or a checking account, and his minimum balance need to be maintained, so already some variables are defined with this. So this is the range, and if it is a high network individual customer, so he maintains a very good transactions and everything, he has $1 billion in his account, so then go for this particular fields. I'm just connecting to the real time. And similarly for the half word, I mean if it is unsigned integer, so 2 4 8, and this is the ranges that we can do. Okay, just to give you a reference, thousands, 100,000 means 6 zeros, million means 3 3, I mean 6 zeros, 5 zeros is 1000, million, billion, trillion. So can you connect anything here? So it is, we pass the $1 trillion here itself. It is more than trillion times, right? So that's where that is a value that we can store on these variables. I'm not sure about any other language. So I think even Java or C Sharp, so it has more. I mean, in fact, so mainframe designed way long back, more than when Java.NET or anything was there. So see, imagine their the way designed some 30-40 years ago. So the way they were imagining these things, and they were calculating these things, right? So that is the reason we say the mainframe has a huge power, right? It can process $1 trillion transactions. Okay, so I'm just trying to compare with Java versus COBOL here. So how the ranges falls here. Okay, so that's it about the comp variables that I wanted to share my knowledge on this Wednesday talks. Okay, if you want me to show a COMP-3 on the mainframe, just let me show. Okay, so this is the program that I was explaining to you in the PPT. So this is where the things are there, and this, and here what I've done is I've taken another data type which is not a usage class. There is no comp. So just I'm trying to play around with this. Even you too can play around with this, try to calculate and do some operations here, and just try to change, assign some decimal points variables, and try to calculate, and do check the output. Okay, so that's about the COMP-3. Okay, now let me compile this and show you the output, how it will come. Okay, and just similarly run this and see. Okay, so now you can see it's 3 bytes, 2 bytes, 3 3 5, and you can see B. Even I too don't remember the table, so I need to go back to the table and see what B is. So B means AB. Okay, it's a 2, right? Okay, so that's what we see here, right? Okay, so okay, that's cool. So another important point, okay, sometimes, so when we are talking about the ranges, right, so when we are talking about this range, so maybe people might have a thought like this: I wanted to test this range and display them and see that. What happens sometimes is the data may get truncated, and you will be not able to see the expected output. So suppose I wanted to pass some 32767 to this S904, maybe I can just see 2767. So what is happening there? So in the compiler, if you are trying to add this in the if at the beginning of the line, if you try to add this and just execute that, so you will avoid you will be not having any issues, especially when you are working with the comp variable. Just add this in the compiler option, or just you can directly add in your COBOL code, so that that problem you will be not able to see that. Okay, so that's it about the comp. I hope it is clear, and if anyone is having any doubts or comments, just you can put down your notes on the comment section. I'll definitely answer them. Okay, so that's it, and thank you so much for watching, and please do subscribe, like and comment, so and share it. Okay, thanks a lot.